See the next question. Show that semi-vertical angle of right circular cone of given surface area and maximum volume is sine inverse 1 by 3. So here we have to prove when volume of the cone is maximum. So we have to prove the semi-vertical angle is equal to sine inverse 1 by 3. So here it is given surface area of the cone is constant. Okay. So for that, let's write surface area. Here surface area means total surface area, that is curved surface area plus base surface area. Okay, that is surface area is equal to curved surface area is pi RL plus this base area, that is pi R square. Okay, and here we have to replace what is L. See, it is given S is constant. See, when we differentiate it, see, we should get only one variable and some others should be constant. Okay. So here for that we are replacing, that is here we will get what is L. Okay. First of all, let us write what is L here. See, S minus pi R square is equal to pi RL. That implies L is equal to S minus pi R square divided by pi R. Okay. That is L. And see, what is our function? Volume of the cone, right? That is volume of the cone is equal to 1 by 3 pi R square h. See, first of all you have to write let h be the height and r be the radius and L be the slant height of the cone and alpha be the semi-vertical angle of the cone. Okay. So here V is equal to 1 by 3 pi R square h. Okay. Now let's substitute what is h here. See, because we are going to differentiate it. See, when we differentiate it, we should get only one variable and some other should be constant. Okay. So we have to differentiate, replace what is h. See, from this figure we will get what is h. We know that L square is equal to, by Pythagoras theorem, L square is equal to h square plus r square, right? H square plus r square. Okay. It's a right angle triangle. Okay. So here from this equation we will get h square is equal to L square minus r square. So what is h? Okay, so pi R square into h is nothing but square root of L square minus R square. Okay, see, we have to differentiate it, right? So let's find V square. We know that if V square is maximum, we have to prove it is maximum, right? So maximum volume. So we have to prove it is maximum. So we know that if V square is maximum, then V is maximum, right? So it is better to squaring on both sides so that this square root will be removed. Okay. So we will prove V square is maximum. So here V square squaring on both sides. So it will be 1 by 9 pi square R raised to 4 into L square minus R square. Okay. 1 divided by 9 pi square R raised to 4 into L square minus R square. Okay. So here what we have to replace L, right? What is L? See, L is here, right? So let's substitute what is L here. So 1 by 9 pi square R raised to 4 into L square is S minus pi R square whole square divided by pi square R square. Okay, L is this one. So here we have to substitute L square, right? So L square is equal to S minus pi R square whole square divided by pi square R square. Okay, that is minus R square. Okay, then let's simplify this one before differentiating. 1 by 9 pi square R raised to 4 into here let's expand this a minus b whole square. So s square plus pi square R raised to 4 minus 2s pi R square. Okay, divided by pi square R square minus R square. That is equal to 1 by 9 pi square R raised to 4 into here take LCM, cross multiply. So s square plus pi raised to 4 pi square R square R raised to 4 minus 2 pi s R square minus here pi square R raised to 4 pi square R raised to 4 divided by pi square R square. See, this pi square R raised to 4 pi square R raised to 4 cancelled. Okay, so remaining, that is here also see pi square r square. Okay, so this pi square r square cancelled. Okay, here it will be square. Then 1 by 9 r square into s square minus 2 pi s r square, right? That is equal to 1 by 9 r square s square minus 2 by 9 pi s r square into r square r raised to 4. Okay, it is our v square. Now let's differentiate it. dv by d, here dv square, okay, dv square by dr, first derivative with respect to r, that is equal to, here 1 by 9 s square is constant, here it is given the surface area is constant. Okay, so 1 by 9 s square is constant, only the variable is r. Okay, so we differentiate it with respect to r. So that is 1 by 9 s square by 9 into derivative of r square is 2r, minus here 2 by 9 pi s is constant, 2 by 9 pi s is constant, derivative of r raised to 4 is 4r cube. That is equal to 2 by 9 s square r minus 8 by 9 pi s r cube. Okay. See here we have to find the value of r, right? So let's take dv square by dr is equal to 0 to find the value of r. That is equal to 0 means this one is equal to 0. That implies 2 by 9 s square r, that is equal to 8 by 9 pi s r cube. That implies here r cancelled and 2 by 9 cancelled. So remaining s cancelled. So here it will be s cancelled. So remaining s, here r cancelled. That is equal to, here 2 by 9 cancelled. Here 2 by 9 cancelled. So remaining 4 pi s cancelled. So r square. Okay. That implies r square is equal to s divided by 4 pi. Okay. That implies r is equal to root of s by 4 pi. Okay. Then, so here we have to prove it is maximum, right? So let's find second derivative. Now let's find the second derivative of v square, that is d square v square by dr square, that is equal to, here 2 by 9 s square is constant, so into derivative of r is 1, so therefore 2 by 9 s square into 1, minus here 8 by 9 pi into s is constant, derivative of r cube is 3r square, so 3 into 8 24 divided by 9 pi s r square. It is our second derivative. Okay. Now here we have to prove this is maximum, that is volume is maximum when r is equal to root s divided by 4 pi. Okay. That is this d square v square by dr square is less than 0 when r is equal to this one. Okay. So let's take, when r is equal to root of s by 4 pi, d square v square by dr square is equal to 2 by 9 s square minus 24 by 9 pi s into r square. R is this one, r square is s by 4 pi. Here pi cancelled, then it will be 2 by 9 s square minus 24 s square divided by 36. That is 12 2s are 12 3s are. Okay. So 2 by 9 s square minus 2 by 3 s square. See which is greater, 2 by 9 or 2 by 3? 2 by 3, right? Obviously 2 by 3 is greater than 2 by 9. Therefore it is minus, right? Because a smaller than minus, a small number minus greater number, that is minus, that is always less than 0. Okay. Because 2 by 9 is less than 2 by 3, therefore it is less than 0, and now it is proved that this volume of the cone is maximum when r is equal to square root of s divided by 4 pi. Okay. Now what we have to prove? We have to prove alpha is equal to sine inverse 1 by 3. Okay. So for that, see here alpha, it is alpha. So what is sine alpha? Opposite divided by hypotenuse, right? That is r divided by l. So here alpha is equal to sine inverse r divided by l. Okay. So we have to prove alpha is equal to sine inverse 1 by 3, right? So we have to prove r by l is equal to 1 by 3. Okay, we have to prove r by l is equal to 1 by root 3. 1 by 3, not root 3, 1 by 3. Okay, so let's find r by l. Okay, so what is l? Let's find l. See, here we have to substitute our value of r. That is, value of r is root of s by pi. Let's find. L is equal to s minus pi r square, that is s by 4 pi divided by pi into r is root of s by 4 pi. That is equal to, here pi cancelled. So 4s, take cross multiply, 4 into s, 4s, 4s minus s is 3s, 3s divided by 4 divided by here pi into root of s by 4 pi. Okay, that is, take 4 here, so it will be 3s divided by 4 pi root of s divided by 4 pi. Okay, then it is l. Next, let's find r by l. So what is r? Yes, r is equal to this one. Okay, so r divided by l is equal to root of s divided by 4 pi divided by l is nothing but this one, that is 3s divided by 4 pi into root of s divided by 4 pi. Okay, see here it is the denominator of denominator, so it will go to numerator. Okay, so it will be so s in s root of s by 4 pi into root of s by 4 pi, that is s divided by 4 pi. Okay, divided by this 4 pi will go to here. Okay, 4 pi, because it is the denominator of denominator, and divided by 3s. Okay, see here this 4 pi cancelled, so s divided by 3s, so s cancelled, so 1 by 3. See here we have got r divided by l is 1 by 3. What is r by l? R by l is nothing but sine alpha. So sine alpha is equal to 1 by 3 means alpha is equal to sine inverse 1 by 3. Okay, that is, this implies alpha is equal to, that is r by l means sine alpha. Sine alpha is equal to 1 by 3. That implies alpha is equal to sine inverse of 1 by 3. Hence it is proved. Look at the next question. The point on the curve x square is equal to 2y, which is nearest to the point 0, 5 is. So here we have to find a point on the curve which is nearest to the point 0, 5. Okay, suppose it is the curve. See, if it is 0, 5, then nearest point we have to find. So let's take xy be the nearest point. Okay, and let d be the distance between them. Okay, distance of these points, distance between these points is, we know that distance formula, if x1, y1 and x2, y2 are the points, what is the distance between them? Y2 minus y1 divided by x2 minus x1, right? So here x minus 0 whole square, right? x2 minus x1 whole square plus y2 minus y1 whole square, right? So here square root of x minus 0 whole square plus y minus 5 whole square. Okay, it is the distance. Okay, distance formula. So here that is equal to, let's simplify this one, x square plus x minus 0 x square plus y square plus 25 minus 10y, right? That is equal to, here what is x square is 2y, right? X square is equal to 2y plus y square plus 25 minus 10y. That is equal to, here root of 2y minus 10y is minus 8y. So y square minus 8y plus 25. Okay. So it is equal to root of y square minus 8y, see, plus 16 plus 9. 25 can be written as plus 16 plus 9. Okay. See why? Because see it is nothing but y minus 4 whole square. Y minus 4 whole square plus 9. Okay. See it is given, we have to find the nearest point. Okay. Nearest point means its distance is minimum. Okay. So when its distance is minimum, what is the point on the curve? Okay. So here distance is minimum. So when this d is minimum, this y minus 4 whole square will be 0. Okay. That is d is minimum when y minus 4 whole square is equal to 0. Okay. When it is 0, the d is minimum. Okay. So here that means d is minimum. Y minus 4 whole square is equal to 0 means y is equal to 4. Right. So when y is equal to 4, substitute y is equal to 4 here. What is s? X square is equal to 2 into 4, that is 8. So what is x? X is equal to root 8, that is equal to 2 root 2, right? Plus or minus 2 root 2. So our point is 2 root 2, x is 2 root 2 and y 4. Okay. Then x is minus 2 root 2 and y is 4. So these are the nearest points of 0, 5. Okay. So these are the points. So here in option, so it is the correct answer. 2 root 2, 4. For all real values of x, the minimum value of 1 minus x plus x square divided by 1 plus x square is dash. So here we have to find the minimum value of x, right? So for that, what is our method? Second derivative, right? First derivative, second derivative, find the second derivative, and the second derivative should be less than 0, minimum, right? So okay, greater than 0 at a particular point. Okay. So here, what is that point? We have to find. So here, so let's take, it is f of x. Okay, f of x is equal to 1 minus x plus x square divided by 1 plus x square. Okay, so here we have to find when it is minimum. At what value of x it is minimum. Okay, so for that let's find f dash of x. Okay, f dash of x, apply quotient rule, that is 1 plus x square into derivative of 1 minus x plus x square is 2x minus 1 plus, sorry, minus, right, quotient rule. Okay, minus 1 minus x plus x square into derivative of this is 2x plus 1 divided by 1 plus x square whole square. Okay, that is equal to, let's simplify this one. Here 2x, 1 into 2x, 2x plus 2x square plus 2x cube minus 1 minus x square. Here next, minus 1 into 2x minus 2x minus into minus 1 into 1 minus 1 into 1 minus 1. Okay, then after that minus x into 2x is minus 2x square, this minus, so plus 2x square, then minus x into 1 minus x minus plus x, then after that x square into 2x, 2x cube, so minus 2x cube, so x square into 1 x square, so minus x square, divided by 1 plus x square whole square. Okay, so here, okay, this 2x minus 2x cancelled, then 2x square minus x plus x cancelled, then minus 2x cube plus 2x cube cancelled. Okay, minus x square, 2x square, minus 1. Okay, so remaining here 2x square plus 2x square, that is 4x square. See, minus x square minus 2x square. So 2x square, this minus 2x square cancelled. Okay, so plus 2x square Here minus 1, minus 2 remain. Okay. That is equal, divided by 1 plus x square whole square. That is equal to, here 2 is common, so let's take it out. 2 into x square minus 1 divided by 1 plus x square whole square. That is equal to 2 into, see this can be written as x plus 1 into x minus 1, right, divided by 1 plus x square whole square. Okay, let's find the points. Okay, x value. For that, f dash of x is equal to 0. That implies this one is equal to 0. That implies, see, this one will go to right side. So we will get x is equal to 1 and x is equal to minus 1. Okay, x plus 1 is equal to 0 implies x is equal to minus 1. X minus 1 is equal to 0. That implies x is equal to 1. Okay, now let's find d square with, second derivative, that is f double dash of x. F double dash of x is equal to, find the derivative of this one. That is, again we have to apply quotient rule. Okay, it is our first derivative, right? Yes. So x 1 plus, see, let's find this one. Okay, 1 plus x square whole square into 2 into 2x. Okay, that is 4x minus 2 into x square minus 1, 2 into x square minus 1 into derivative of this one, that is 2 into 1 plus x square whole square, into, not whole square, into 2x plus 1 divided by 1 plus x square whole raised to 4. Okay, then simplify this one. See, after derivation you will get 4 into 1 plus 3x minus x cube divided by 1 plus x square whole cube. Okay, so that is f double dash of x. Now here we have to check when x is equal to 1, whether this f double dash of x greater than 0 or less than 0. Okay, and at x is equal to minus 1, so let's find x is equal to minus 1. When x is equal to minus 1, see, f double dash of 1 is equal to, here, see, substitute 4 into 1 plus 3 into 1, 3 minus 1 cube, minus 1 cube, so minus 1 cube is minus 1, so it will be plus 1, divided by 1 plus minus 1, that will be 0, so minus 1 square, that is 1, so 1 cube, it will be 1, so here it is positive, right, that is greater than 0. Okay, so here when x is equal to minus 1, this f double dash of 1 is greater than 0. That means this function is minimum, right? So here at x is equal to 1, when x is equal to 1, see here f double dash of 1, here it is f double dash of minus 1, okay? F double dash of 1 is equal to 4 into 1 plus, f double dash of minus 1, right? So it is minus 3, okay? It is minus 3, so minus plus 1, so 1 minus 3 is, 1 minus 3 is minus 2, minus 2 plus 1 is minus 1, so it will be less than 0, okay? So it is less than 0, that is 4 into, it will be minus 2, so minus 2 is less than 0, and here next is f double dash of 1 plus 1, okay? So substitute x is equal to plus 1, so 4 into 1 plus 3, that is 4, minus 1 cube, that is 1, divided by, here 1 plus 1, 2, 2 plus 1, that is 3, so 3 cube, that is 9, it is, see, 4 minus 1 is, so 3 into 12, that is 12 by 9, it is greater than 0. Okay, so here it is greater than 0, right? It is less than 0, therefore here it is not the point, okay? So we need minimum, right? So when this function is minimum, so here this function is minimum when x is equal to 1. So 1 is the answer, okay? When x is equal to 1, the function is minimum, okay? Because we have got f double dash of x is greater than 0 when x is equal to 1, okay? That is, the function is minimum when x is equal to 1. The maximum value of x into x minus 1 plus 1 whole raised to 1 by 3. 0 less than or equal to x less than or equal to 1 is. See, here we have to find maximum value of this function. Okay, maximum value of the function. So let's if it is f of x, we have to find what is f of 0, f of 1 and the f of, that is critical points. Okay, value of the function at critical points. So here no need to find a second derivative. Here we will find the first derivative and find the critical points, and we will find the values of the function. Okay, at all the points. That is because here we have to find the maximum value of this function. Okay, so here first of all, okay, f of x is equal to x into x minus 1 plus 1 whole raised to 1 by 3, right? So let's find f dash of x. Okay, see, we can write it as this one, x into x square, that is x square minus x plus 1, right? Whole raised to 1 by 3. Okay, then differentiate it. F dash of x, here we have to find the values of x, that is critical points. So f dash of x is equal to 1 by 3 into x square minus x plus 1 whole raised to 1 by 3 minus 1 is minus 2 by 3, right? That is derivative of x raised to n is n into x raised to n minus 1, right? So in the same way, that is n into x raised to n minus 1, that is 1 by 3 minus 1, that is minus 2 by 3. Okay, into derivative of inside function, that is 2x minus 1. Okay, so it is our f dash of x. That is, okay, here we can write it as 1 by 3, see 2x minus 1, see it is minus 2 by 3, right? So we can write it as x square minus x plus 1 whole raised to 2 by 3. We can take it in denominator, okay, because it is minus 2 by 3. Okay, so 1 by 3 is here. Then, so f dash of x is equal to 0 implies, okay, because we need to find critical points, right? So this f dash of x is equal to 0 implies this one is equal to 0. That implies it will go to right side, it will be 0. So 2x minus 1 is equal to 0, right? So 2x minus 1 is equal to 0. That implies x is equal to 1 by 2. Okay, we have got x is equal to 1 by 2. Now we have to find, see, we have to find the maximum value of this function, right? So here we will find the values of the function. First of all, let's find f of 0. It is the, see, our interval is 0 to 1. Okay, 0 is included because 0 less than or equal to, see, x less than or equal to 1. Okay, 0 and 1 are included. So find, first of all, let's find f of 0. So what is f of 0? It is our f of x. Okay, so substitute x is equal to 0. 0 minus 0 plus 1, that is 1. So 1 raised to 1 by 3, that is 1 itself. Okay, then let's find f of 1 by 2. F of 1 by 2, substitute x is equal to 1 by 2. So 1 by 2 square is 1 by 4 minus 1 by 2 plus 1 whole raised to 1 by 3. That is equal to, here take the LCM, 4 is the LCM. So 1 minus 2 plus 4, that divided by 4 whole raised to 1 by 3. That is equal to, here 1 plus 4 is 5, 5 minus 2 is 3, 3 by 4 whole raised to 1 by 3. Okay, next last point, that is f of 1. F of 1 is equal to, substitute x is equal to 1 here. So 1 minus 1, 0. Okay, here you have to substitute x is equal to 1 in f of x. Okay, because we have to find the maximum value of the function. Okay, so here f of 1, substitute x is equal to 1. So 1 minus 1, 0 plus 1. So 1 raised to 1 by 3, that is 1. Okay, so here we have to find maximum value, right? So which is maximum among these values? So maximum value of f of x is equal to maximum of these values, that is 1, 3 by 4 whole raised to 1 by 3 and 1. Okay, see, 3 by 4 is nothing but that is less than 1, right? 3 by 4 is less than 1. Its cube root is always less than 1, right? So here maximum is nothing but 1. Maximum value is 1. So maximum of among these values is 1. So our answer is 1.